This is the tutorial on topic 8 related to Faraday's law. Okay, so this is the first question. A solenoid has a radius R1 equals to 1 centimeters. The total number of turns per meter is 2000 per meter, and the length is 50 centimeters. And then the smaller solenoid has a radius R2, 0.5 centimeters, and then the number of turns per unit length or per meters is 5,000, and then the length of the smaller solenoid is 10 centimeters, and then they are placed, or the smaller solenoid is placed inside the larger solenoids, and asked to work out the mutual inductance between them. Radius is 1 centimeter, length (50 centimeter). This one's length is 10 centimeter, and then radius of this is 0.5 centimeters. This one, number of turn N1 is equals to 2000 per meter. This one is N2 equals to 5,000 per meter. Okay, so if you want to find the exact number of turns, you multiply it by the length, then you can find out what is N2. Will be okay, if you want to find out what is the actual number of turns for each of the solenoids. Let's start with the large solenoids. So we know that the magnetic flux are mainly concentrated inside the solenoids. Okay, so we can actually apply Ampere's law. Okay, so if we choose to loop in this way, so this is the current that flowing and therefore this will be equals to mu naught I times N. Okay, because there is N or N1 number of turns of wire. And then we said that the magnetic flux is mainly in this path, and then outside the magnetic flux is negligible. Okay, therefore we can say that B dl is roughly equals to B times L1. And therefore B, or I call it B1, will be equals to mu naught I N1 over L1. And then N1 over L1 is our number of turns, small letter n times I. And this magnetic flux is filling within this area A. Therefore, the magnetic flux so this is the flux inside here. And then we have a smaller solenoid sitting inside the large solenoid. Okay, so my flux one, phi 1, only part of this flux is actually cutting through my second solenoid that has an area A2. So the flux threading through small phi 2 equals to B1 A2. The flux linkage equals to N2 times the flux. N2 is and then phi 2 is this. And then B1 is this value here. Then we can calculate the mutual inductance. Equals the flux linkage divided by the current I1. Putting all the value in, you should get about 99 microhenry.